Every single time that you think about solving an equation, at the end, you should always have what? The variable should be what? It should be all alone and positive. The variable, okay? So again, every single problem that's an equation should have a variable in it and it should have an equal sign, right? An equal sign is what makes an equation an equation. So we always want our variable to be all alone and positive. Does that mean that I cannot get a negative answer? No, that means my variable can't be negative, right? So, k is equal to 6. My variable is all by itself and it's positive. K is equal to negative 13. It doesn't matter that my answer is negative, it's only my variable that can't be negative. Okay, so that's our goal. And then we're going to use inverse operations. What does the word inverse mean? Opposite, right? So the other day we did addition and subtraction, they're partners. So what's today? Multiplication and division. So we're going to solve equations with multiplication and or division. Again, I abbreviate sometimes. If you don't know my abbreviations, raise your hand and ask. Multiplication. What are ways that I can show multiplication again? Dot, an x. Now we kind of throw out the x because it looks too much like a variable, right? What else? Put it together if I have a variable and a number, or two variables. Or use parentheses, right? Okay. Division. How do I show division? By a fraction, which is probably the most common way that we're going to do it anymore. Or using the little division symbol. Did anybody ever find out what that division symbol's name is? Wasn't that extra credit one day? So, the first person tomorrow that can tell me what the name of that symbol is, you get extra credit. Okay? So we could use that symbol. We could go old school and use the box, but that's not going to really be done anymore. Okay, so we're going to use inverse operations though. And then you got to think about signs, right? So the rules with signs revolves around the answer sign. And really in multiplication and division, it's the same rules, right? What are the rules for the answers of my sign? If the signs are the same in the problem, in multiplication and division, what's my answer? Positive. Always positive. If my the signs of the problem are different, my answer is always negative. Doesn't matter which one comes first or which one is bigger or smaller, right? Those are the rules for multiplication and division. Okay? So, these problems today are pretty simple because we don't get into fractions yet, and we're just basic multiplication and division problems. So let's look at it. 8a equals 48. So again, the biggest thing is that I recognize that it is multiplication, right? That this 8a means 8 times a, but Carson said I can write them together, right? So if it is multiplication, what am I going to use to get rid of it? Division, right? So remember, I'm always going to divide by the, what would I call this 8? What vocabulary word would I call that 8? Coefficient. The coefficient, right? So I'm always going to divide by the coefficient with the variable. So I'm looking at the variable, wherever it is, and I'm looking at the coefficient, and that's what I'm going to divide by. If this is negative, I divide by a negative number also. If this is positive, I divide by a positive. So I'm going to divide by that coefficient. Whatever I do to one side, I have to do to the other side. Why do I do that? Because if I don't multiply or divide by the same number on both sides, add and subtract by both numbers or the same number on both sides, I mess up the problem. Because it's not 1 to 1. But if I divide by 8 and divide by 8, I'm basically dividing 8 divided by 8 is 1, right? I can divide anything by 1 because what do I get? The same thing, right? That's why this works. So, my 8s do what to each other? They cancel out. In division, they cancel out and give you what? 1, right? Because I'm dividing. 8 divided by 8 is 1. That's a big misconception. Yesterday, or the other day when we did adding and subtraction, they actually cancel each other out and give you 0. Now they give you 1. Okay? And then I just do my division. What's 48 divided by 8? So A is equal to 6. Look, my variable is all by itself and it's positive. Every single time I should take 2 seconds and do what? Put it back in. Is 6 times 8 48? Yeah. So again, these should be relatively simple because they're all going to be pretty basic problems. Okay. Then we could get a negative number, right? Negative 3k is equal to 27. So the exact same thing, but now we're going to divide by what? Always divide by that coefficient. So I'm going to take the sign with it. Okay? If I divide the left-hand side by negative 3, I have to do that on the right-hand side. Again, look, I want the exact same number here, right? Because the exact same number cancels each other out and gives me 1. So k is equal to what? So, if you need to come back here, always divide by the coefficient. Use the sign. Don't forget about the sign. And then, honestly, it doesn't matter if we write the answer first. Right? So in this one, we're going to get what? What am I going to divide by? Negative 9. Do that on one side, got to do it on the other side. My negative 9's cancel out, right? Negative 9 divided by 9 is 1 or z. 1 times z is z. And then over here we get what? 5. So is 5 times negative 9 negative 45? Heck yes, right? Piece of cake. That's all I got to do for those ones. Any questions there? Okay. So then division is just the opposite, right? As Carson said, we're mainly going to have problems that use my fraction. Okay? Remember now, the thing that we want to do now, so we're going to solve over here division problems. So if I'm solving division problems, I'm going to use multiplication, right? But remember, one of the things, this is a big star, we've already talked about this. Remember, if I have m divided by 2 and they put a minus sign out here or a negative sign, where can I really put that negative sign? I can put it anywhere, right? Remember, this is still the same. That's still the same. So all 3 of those are still the same. Ladies and gentlemen, if there's a negative in the problem, I'm always going to do this one because I want the negative to be with the number, right? Because my main goal is that the variable is all alone and positive. So you could put it with this one right here, but then you'd have to do another step. A lot of you don't like to do the necessary steps, let alone another step. So put the negative with this 2 down on the bottom, or whatever the number is on the bottom. Always put the negative with the number. Okay, not the variable. Understand what I'm saying there? Okay, so, example. Y over negative 5 equals negative 12. So again now, you have to recognize that we have a division problem. And as the gentleman said, one of the best ways to show division now is to use a fraction. So I'm going to now always, we're going to multiply by the number in the denominator. What's my denominator? The number on the bottom. And again, another star here. Use the sign. So, as soon as I recognize that it's division, I know that I'm going to multiply by the denominator. So I'm going to show that to myself. Multiply by the denominator. When I multiply by the denominator, it's actually going to go on top. Because I can make this into a fraction by doing what to any number? How can I make any number into a fraction? Put the number over what? 1, right? And if you haven't thought about multiplying by fractions a lot, the reason that we do it this way is because every time that we multiply fractions, we should always look to reduce diagonally first. What does reduce mean? Simplifying, right? So basically, I'm taking -5 and -5, and they're canceling each other out. But again, notice, I multiplied by a negative, so I have to multiply by a -5 over here also. Whatever I do on one side of the equation, I have to do on the other side. So again, my -5's diagonally, they cancel each other out. They're basically dividing each other out, and I'm left with my y. So y equals, notice it's all by itself and positive, -12 times -5. Positive 60, right? Two negatives make a positive. Last but not least, put it back into the original problem. Is 60 divided by -5? -12? I think so too. Okay? You try one out. N over -6 equals 11. My shoes are really squeaky today.
What'd you step in?
I don't know. I think it's just the floor. What'd you come up with?
66.
What'd you multiply by? -6, right? Multiply by -6 on the left-hand side. I have to multiply by -6 on the right-hand side. My -6 cancel each other out. So I'm left with n equals 11 times -6 is -66. Okay? Questions with that? Hopefully this isn't too difficult. Okay? The thing that might be difficult are story problems again. So let's look at a story problem. Esteban spent $112 on baseball cards. If he spent $14 per box, how many boxes did he buy? What do you think? Could I make a problem by that paragraph? What problem would I make?
B over 14 equals 112.
D over 14?
No, over 112.
What do you think? Is he right? What do we really want to do? Yeah, but what do we really want to do mathematically? In the problem. What do you think?
Figure out how many boxes you bought.
Right. So what do we want to do mathematically? What operation do we really want to do? We do? We want to divide, right? So if we want to divide, what do we really need to show as my problem? If I want to divide, I really want to show multiplication, right? So using 14, what would I take 14 by to get the grand total of $112?
8.
Well, yeah, but what would go in my parentheses? 8 would, but if I wanted to write this as a general variable, right? So we would say cards, right? Or dollars. So 14 times the what are they asking? How many boxes? Yeah. So how many card boxes did we get? That we spent $112. So it is 8 because we would take and divide by 14 on both sides, right? So C equals. And then 8 what? What's my label? Boxes, right? So again, remember, anytime that I have a story problem at the end, I should always have a label on it. Whether it be money or, in this case, boxes. Okay? Questions? That's all that's in this section. Now, here's the kicker. So we got about, I don't know, 8 minutes to write down the assignment, and you can start on the assignment. But tomorrow, already, is a quiz again. So these sections are so important, I want to hammer this into you.
So is it just over?
So, what is it on? Not only is it on multiplication and division, but it's also on simplifying, because we had so many problems with the simplifying ones. So, simplifying and multiplying and dividing. For tomorrow, okay? Or that's what we'll do tomorrow. And again, if you have problems with those ones, come in and see me today. We'll sit down and work through them. Oh, there are some addition and subtraction ones on there. So there's only 4 of those, and then you got some multiplication and division ones, and then 4 of the simplifying ones. Make you think a little bit.